Chapter 1, Section 2, Using a Scientific Approach. Today we're going to look at the scientific method. Most of you should know what that is already, so we'll go through this pretty quickly. The first thing that you should know about the scientific method is that it's an organized plan for gathering, organizing, and communicating information among the scientific community. The goal of the scientific method, or any scientific method being used, is to either solve a problem or to better understand an already observed event. So because we're talking about an observed event, the first step is to make an observation. Observation is anything or any information that you're obtaining through your 5 senses. Once you have gained information, you need to form a hypothesis or state the problem. So you need to come up with a proposed answer to some question. So if your question is why the sky is blue, okay, that's your question. Maybe your hypothesis is that the sky is blue because it reflects off of the ocean water. Okay, that would be one example. Once you have your hypothesis, you need to test that hypothesis. You need to perform some experiments. And there's some important information that you need for those experiments. So you need an independent variable and a dependent variable. The independent is the variable that causes change in another variable. It's also called the manipulated variable. Okay, so that's the one that you change that's being manipulated. So for example, time is constantly changing. Time is independent because it doesn't depend on anything else. So time is your manipulated variable. Dependent, on the other hand, is the variable that changes in response to that initial or an independent variable. So your dependent variable, so for instance, your, let's say your speed. So over time, if you're at a red light and you hit green and you're ready to go, over time you're going to speed up. So the dependent variable changes based on the amount of time you are away from that red light. So dependent variable is also known as the responding variable because it's responding to the change your independent variable made. Now, aside from independent and dependent, we also have controls and constants. So a controlled experiment is where you are only changing one thing. Okay? You are only changing the independent variable one piece at a time. Okay, so if we're looking at time, you're changing it by 1 second. If you're looking at time, you might change it by 1 minute, or maybe 1 hour might be your time change. Okay, all of the other variables are kept constant or are kept controlled. So if we're looking at the time, and that's what we're changing, maybe I want to know what is your speed 1 minute away from your house, 5 minutes away from your house. You're changing the time, but your speed is changing as well. Everything else should be kept constant. Okay? So when I say constant, that's something that stays the same. It remains unchanged. Once you have tested and conducted your experiment, you need to draw conclusions, and this is where you need to decide, is your hypothesis supported or unsupported? So were you right in your proposed answer, or were you wrong? And it's okay to be wrong. You do not have to be right with your hypothesis. There are scientists out there every single day who have their hypothesis wrong, but guess what? They keep testing. Okay? Just because you're wrong doesn't mean it's a failure. The only true failure is to never try again. So once you have drawn your conclusions and you've decided if your hypothesis was supported, that means you test again to make sure you're correct. Or if it's not supported, you go back and you change some things. Then you need to develop a theory. You need to report your results. So submit an analysis. So when we're talking about a theory, that means it has been well tested. You don't just test it once and if you're right, you move on to the next thing. It has to be tested hundreds upon thousands of times. Okay? Just to double check your results. And it's not going to be that just you are testing it. Other scientists need to be able to test your experiment as well and come out with the same results. Now, there is a difference between what we call a theory and what we call a law. A theory is the explanation, so why it happens. A scientific law is just a statement of what is happening. Okay? So, for example, the law of gravity states that there is a gravitational field pulling you toward the Earth. It doesn't tell you why, but it tells you that there is, and that's okay. Some other things that you need to know for this chapter, scientific models, those are representations of objects or events that we can't clearly see on our own. So it makes it easier for us to understand things. For example, in my classroom on one of my walls, I have a image painted of the solar system. The solar system is not something that we can see with the naked eye. It's much too vast. But by looking at that painted picture, we can get some kind of a semblance of the shapes, the sizes of all of the planets that we have in our solar system. Same thing goes for something that's super tiny. The Bohr model of the atom shows us a representation of what an atom looks like when atoms are on a micromolecular level that we can't see with our human eye. One last thing for today, science safety. Always, please always follow teacher instructions when we have labs or just in class in general. And please follow instructions that you have on your lab safety or your lab procedures or textbook directions. Okay? So for example, Carol never wore her safety goggles. She said YOLO instead. And that's it for today.